This example shows you how to read analog input from the physical world using a potentiometer. A potentiometer is a simple mechanical device that provides a varying amount of resistance when its shaft is turned. By passing voltage through a potentiometer and into an analog input on your board, it is possible to measure the amount of resistance produced by a potentiometer as an analog value. In this example, you will monitor the state of your potentiometer after establishing serial communication between your Arduino and your computer running the Arduino software, IDE. Connect the 3 wires from the potentiometer to your board. The first goes from one of the outer pins of the potentiometer to ground. The second goes from the other outer pin of the potentiometer to 5 volts. The third goes from the middle pin of the potentiometer to the analog pin A0. By turning the shaft of the potentiometer, you change the amount of resistance on either side of the wiper, which is connected to the center pin of the potentiometer. This changes the voltage at the center pin. When the resistance between the center and the side connected to 5 volts is close to 0, and the resistance on the other side is close to 10 kilo-ohm, the voltage at the center pin nears 5 volts. When the resistances are reversed, the voltage at the center pin nears 0 volts or ground. This voltage is the analog voltage that you're reading as an input. The Arduino boards have a circuit inside called an analog-to-digital converter, or ADC, that reads this changing voltage and converts it to a number between 0 and 1023. When the shaft is turned all the way in one direction, there are 0 volts going to the pin, and the input value is 0. When the shaft is turned all the way in the opposite direction, there are 5 volts going to the pin, and the input value is 1023. In between, analog read returns a number between 0 and 1023 that is proportional to the amount of voltage being applied to the pin. In the sketch below, the only thing that you do in the setup function is to begin serial communications at 9,600 bits of data per second between your board and your computer with the command serial begin. Next, in the main loop of your code, you need to establish a variable to store the resistance value, which will be between 0 and 1023, perfect for an int date type, coming in from your potentiometer. Finally, you need to print this information to your serial monitor window. You can do this with the command serial.println in your last line of code. Now, when you open your serial monitor in the Arduino software, IDE, by clicking the icon that looks like a lens on the right in the green top bar, you should see a steady stream of numbers ranging from 0 to 1023, correlating to the position of the pot. As you turn your potentiometer, these numbers will respond.